On April 15, 1943, at an altitude of 20,000 feet above the French coastline near Dieppe, Major Donald Blakesley gripped the control stick of his P-47 Thunderbolt as he spotted a familiar outline piercing the cloud layer below. After enduring weeks of rigorous training sorties and recurring mechanical setbacks with the new Republic P-47 seconds, the 4th Fighter Group was finally engaging the enemy in combat. These American heavyweights, derisively nicknamed 7-ton milk bottles by British pilots, were about to demonstrate their formidable capabilities. Through the sights of his guns, Blakesley tracked a Focke-Wulf 190 from JG-26 Schlager, unaware that he was on the verge of making aviation history. When he closed the distance to approximately 300 yards, he squeezed the trigger. The P-47's 8 Browning AM-250 caliber machine guns unleashed a synchronized torrent of bullets, each capable of firing 800 rounds per minute. In theory, the aircraft could deliver a combined 6,400 rounds per minute, a staggering concentration of firepower. The German fighter, armed with two 20mm 150-120 cannons and two 7.92mm MiG-17 machine guns, was quickly reduced to fragments by the concentrated armor-piercing incendiary fire. This engagement marked the P-47's inaugural aerial kill and signaled a paradigm shift in fighter combat. The Americans had not merely built a new plane, they had engineered a flying weapons platform that leveraged industrial production to redefine air combat power. The P-47's journey to this moment began months earlier. Its first operational sortie took place on March 10, 1943, when the 4th Fighter Group undertook a fighter sweep over French territory. That initial mission was hampered by radio failures, forcing the pilots to return to base and replace their radios with British equipment. During the early months of 1943, the squadron, originally part of the RAF's Eagle Squadron, struggled to adapt from the agile Spitfires to the substantially heavier and less maneuverable Thunderbolts. The P-47 was an imposing machine weighing 12,731 pounds empty and reaching 17,500 pounds when fully loaded, more than double the mass of a Messerschmitt Bf-109G. Yet Republic Aviation, headquartered in Farmingdale, New York, was producing these aircraft at an extraordinary pace. By April 1943, assembly lines were delivering one completed P-47 every 4 hours, with production numbers steadily increasing each month. Alexander Kartveli, the Georgian-born chief designer, approached fighter development with a philosophy that European engineers often considered extreme: prioritize maximum firepower through mass production. Where German designers obsessed over shaving grams from their aircraft, Kartveli added armor, weaponry, and ammunition without hesitation. This approach was appreciated by officers like Colonel Hubert Zemke of the 56th Fighter Group. Arriving in England in January 1943, Zemke's unit began combat missions by April and would ultimately fly only P-47 seconds throughout the war, accumulating 674 confirmed victories. The combat effectiveness of the P-47 was rooted in straightforward mathematics. Early P-47C and P-47D variants carried a total of 2,800 rounds distributed across 8 guns, 4 mounted on each wing. These guns were calibrated to converge at a distance of 250 yards, creating a zone of exceptional fire density. Within this zone, a 1-second burst would unleash 107 armor-piercing incendiary projectiles, each traveling at nearly 2,840 feet per second, a rate of destruction unprecedented in single-engine fighter engagements up to that time. The first P-47 victory not only validated Kartveli's design principles, but also underscored a broader shift in air warfare strategy. Superior production capacity combined with concentrated firepower could decisively influence aerial combat, changing the rules of engagement for the remainder of the war. Initially, Luftwaffe intelligence dismissed the early reports concerning the P-47 Thunderbolt's firepower as exaggerations. The idea that a single-engine fighter could reliably operate 8 heavy machine guns seemed, by German technical standards, almost impossible. At the time, German aerial combat philosophy prioritized precision and efficiency over sheer volume of fire, equipping fighters with just enough weaponry to destroy an enemy plane while preserving performance and maneuverability. During the spring of 1943, the primary Luftwaffe fighter in Western Europe, the Focke-Wulfs FW-190s, carried a relatively modest arsenal, two 7.92mm MG-17 machine guns with 1,000 rounds each, supplemented by two 20mm MG-150-120 cannons in the wings, each stocked with only 250 rounds. While the 20mm explosive shells were far more destructive on an individual basis than standard .50 caliber bullets, their limited supply demanded highly accurate shooting. German pilots had developed combat techniques built around this constraint, favoring short, deliberate bursts at close range, a method that proved effective against British Spitfires and Hurricanes, which themselves generally carried 8 rifle-caliber machine guns or combinations of machine guns and cannons with similarly tight ammunition limits. After Lieutenant Blakesley scored the P-47's first confirmed kill on April 15, 1943, encounters between Thunderbolts and Luftwaffe fighters increased rapidly. Just 2 days later, on April 17, P-47 seconds of the 4th Fighter Group undertook their first bomber escort mission. Although the range limitations of early external fuel tanks forced them to turn back sooner than planned, German pilots were immediately struck by the aircraft's overwhelming firepower. The visual effect of 8 guns firing simultaneously was unlike anything they had previously faced. Compounding this was the P-47's standard ammunition mix: 4 armor-piercing incendiary rounds followed by 1 tracer, creating the illusion of a nearly continuous stream of light during combat rather than discrete bullets. By May 1943, the Luftwaffe had begun analyzing captured P-47 components at their aircraft testing center. Engineers were astonished by the Browning M2 machine gun's reliability. Though originally designed in 1933, mass production had refined the weapon to a degree where all parts were fully interchangeable, a level of standardization German industry could not replicate. Its ammunition feed system used disintegrating link belts that were ejected cleanly from the aircraft, unlike German systems which relied on either drum magazines, limited to 6,200 rounds, or belts that retained the links, adding both weight and mechanical complexity. This level of reliability allowed American pilots to potentially unleash their entire ammunition load in a single, sustained burst without fear of jamming. The sheer scale of American ammunition production further shocked German analysts. By mid-1943, the 8th Air Force routinely flew over 200 P-47 sorties per day, with each aircraft carrying 2,800 rounds. Pilots typically expended around 60% of their ammunition per mission, resulting in roughly 336,000 rounds fired daily, exceeding the total weekly allocation for all German fighter units in France. The Lake City Army ammunition plant in Missouri alone had achieved an annual production capacity of 1.66 billion rounds by 1943, outproducing Germany's entire small arms ammunition industry. The facility operated continuously with 20,000 workers rotating in shifts, adhering to rigorous quality controls that rejected any rounds deviating more than 0.001 inches from specifications. Aircraft production at Republic Aviation was similarly impressive. The Farmingdale facility spanned 765,000 square feet, supplemented by a secondary plant in Evansville, Indiana. By late 1943, combined output exceeded 400 P-47 seconds per month, while German fighter manufacturing of all types struggled to surpass 1,000 aircraft per month. German designs had traditionally favored lightweight, highly maneuverable planes such as the Messerschmitt Bf-109G6 at 6,940 pounds fully loaded and the FW-190s at 9,040 pounds, emphasizing agility over raw firepower. In contrast, the P-47 combined robust construction, exceptional firepower, and industrial scale, creating a new benchmark in air combat that German pilots were only beginning to comprehend. The P-47C Thunderbolt had a fully loaded weight of approximately 13,500 pounds, while the subsequent P-47D model climbed to around 14,500 pounds, an astonishing mass that far exceeded what German designers typically considered manageable. Despite this heft, the aircraft's Pratt & Whitney R2800 double Wasp radial engine delivered between 2,000 and 2,300 horsepower depending on the version, ensuring that the P-47 maintained The substantial weight, rather than being a liability, provided remarkable stability when firing its heavy armament and allowed the aircraft to withstand severe battle damage that would have crippled lighter fighters. A key element in this resilience was the General Electric turbo supercharger, weighing 845 pounds alone, almost the same as the entire weapons load on a typical German fighter, but capable of sustaining full engine power up to 30,000 feet. By comparison, the BMW 801 engine in the Focke-Wulfs 190 experienced a significant drop in performance above 20,000 feet, leaving German pilots at a disadvantage in high-altitude engagements. The sheer intensity of the P-47's firepower forced the Luftwaffe to rethink traditional tactics immediately. Conventional attack runs, which had worked well against earlier Allied fighters, became almost suicidal in the face of sustained P-47 volleys. American pilots did not need to achieve the optimal firing position to be effective. The concentrated fire from 850 caliber machine guns created zones of near-certain destruction. German pilots, in contrast, could not safely cross a P-47's path without facing heavy casualties. Units had to adopt new tactics that leveraged the FW-190s' superior roll rate and maneuverability at low altitudes. However, reaching the low-level engagement zone required flying directly into the P-47's lethal firing range, US. Pilots exploited altitude advantage and heavy armament to force German aircraft into unfavorable positions, controlling the dynamics of aerial combat. The difference in ammunition doctrine was striking. German pilots typically carried enough rounds for only about 1 minute of continuous firing, while the P-47's load allowed for half a minute of non-stop fire. This contrast shaped tactical behavior. Luftwaffe pilots fired cautiously to conserve ammo, while Americans engaged with a much more liberal firing policy. The August 17, 1943 mission to Schweinfurt and Regensburg illustrated these strengths and limitations. Within their escort range, P-47 squadrons inflicted severe losses on German interceptors. For instance, the 56th Fighter Group claimed 17 enemy aircraft without suffering a single loss. Yet the P-47's range, even with auxiliary 75-gallon drop tanks, restricted the protective escort zone to roughly 375 miles from their bases. German controllers quickly recognized this and began timing attacks to occur once the P-47 seconds had returned to base, leading to significant bomber losses outside the aircraft's defensive envelope. To address the range limitation, the US progressively introduced larger drop tanks, first 108-gallon and later 150-gallon, which extended operational reach to about 425 miles by October 1943. Every incremental increase forced German fighters to wait longer before striking and to travel further into enemy territory, complicating their operations. The logistical and industrial support for P-47 squadrons was unparalleled. Each unit maintained vast reserves of ammunition, sometimes up to 500,000 rounds, while forward airfields in England stockpiled millions more. Continuous shipments from American factories ensured that P-47 units could operate at maximum intensity for a month without resupply. By contrast, Luftwaffe squadrons often had just a few days' worth of ammunition on hand. This disparity extended to maintenance and spare parts. American depots held complete replacements for engines, gun assemblies, and major airframe components, enabling rapid turnaround for damaged aircraft. German units, constrained by shortages, were frequently forced to strip damaged planes to keep others operational, weakening overall effectiveness even when airframes could theoretically be repaired. The October 14, 1943 raid, later termed Black Thursday, highlighted both sides' capabilities. P-47 seconds escorted bombers to the edge of their range, downing 21 German aircraft, but bomber losses skyrocketed once the escorts returned to base. German pilots increasingly recognized the lethal consequences of engaging the Thunderbolt head-on. The numerical and logistical imbalance was stark. A standard Luftwaffe staffel of 12 aircraft might carry around 7,000 rounds of mixed calibers, while a single P-47 squadron of 16 aircraft had nearly 45,000 rounds ready for immediate use, with millions more in reserve. The advantage in firepower was further compounded by training. American pilots entered combat with over 400 flight hours, including more than 100 hours devoted to gunnery practice and thousands of rounds fired in training. German pilots, by late 1943, averaged just 110 hours total, with perhaps 20 hours of actual gun practice. Fuel shortages further limited training opportunities, leaving many Luftwaffe aviators underprepared. In effect, American pilots often fired more ammunition in practice than their German counterparts would in their entire combat careers. Lieutenant Colonel Francis Gaby Gabreski, who would eventually become the leading P-47 ace in the European theater with 28 confirmed kills, summarized the operational reality of these encounters. The Thunderbolt's combination of firepower, ruggedness, and sustained high-altitude performance forced the Luftwaffe into fundamentally new tactical approaches and highlighted. During the early stages of P-47 deployment, aircrews discovered that superior marksmanship was less critical than simply keeping their sights on enemy targets and sustaining fire. The aircraft's formidable 50 caliber guns performed the bulk of the work. By late 1943, P-47 squadrons had shifted their focus from purely escorting bombers to aggressive ground attack missions. The 50 caliber armament proved highly effective against locomotives, vehicles, and stationary aircraft. Using armor-piercing incendiary rounds, a single aircraft could penetrate train boilers or vehicle armor, often obliterating an entire train in a single strafing pass. Typical attack tactics involved a shallow dive of approximately 30 degrees. Pilots would commence firing from around 1,000 yards and manipulate the rudder to sweep bullets across their target, pulling out just above 200 feet. Within a brief 10-second window, a P-47 could unleash between 800 and 1,000 rounds over a target stretch roughly 100 yards long. This relentless assault systematically disrupted German transportation lines. Locomotives and rolling stock were destroyed faster than German industry could replace them, forcing units to limit daytime rail movements by December 1943 due to the persistent threat from P-47 attacks. In addition to ground attack, the P-47 played a critical role in the Allied strategic bombing campaign. While the P-51 Mustang would eventually dominate long-range escort duties, the P-47 initially provided a protective screen, allowing bombing operations to continue despite significant losses. By early 1944, enhanced P-47D variants carried 425 rounds per gun, totaling 3,400 rounds. The D-25 model introduced a bubble canopy, a paddle blade propeller, and the capability to mount rockets alongside its guns, sustaining combat efficiency even as German fighters grew more capable. D-Day, June 6, 1944, highlighted the aircraft's capabilities on an unprecedented scale. P-47 seconds conducted 2,398 sorties over Normandy, claiming 84 enemy aircraft in the air and 89 on the ground. Even more consequential, they effectively immobilized German ground forces through targeted interdiction. Luftwaffe sorties over the invasion zone numbered just 319, in stark contrast to over 13,000 Allied missions. German fighters faced extreme limitations, roughly 200,000 rounds of ammunition in total, while American pilots operated with near unlimited supply and millions of rounds. P-47 seconds established zones of virtual free fire. Any movement was vulnerable to destruction. Convoys and vehicle columns were frequently reduced to burning debris in a single strafing run. The characteristic whine of P-47 seconds diving, amplified by air rushing through gun ports and cooling ducts, became a psychological weapon as much as a physical one. By late 1944, German fighter production reached its historical peak of about 25,000 units annually. However, fuel shortages, pilot attrition, and overwhelming Allied numerical superiority kept the majority grounded. Those aircraft that did see action were often outnumbered 10-1. Even the Messerschmitt Me 262 jet with its superior speed could not offset limitations in firepower. Its 30mm Mk108 cannons carried only 80 to 100 rounds per gun, insufficient for sustained engagements with agile fighters despite their effectiveness against bombers. In the Pacific theater, the P-47N variant introduced extended range capabilities with 550 gallons of internal fuel, allowing it to outperform many German medium bombers in endurance. This reflected the United States' industrial capacity to design fighters that exceeded conventional expectations. Overall, production figures underscore the P-47's significance. 15,683 units were built, with peak monthly output across multiple plants exceeding 400 aircraft. The combination of firepower, durability, and production scale ensured that the P-47 remained a decisive factor in multiple theaters of World War II. Between 1941 and 1945, the Focke-Wulfs FW-190 series reached a total production of roughly 20,000 aircraft across all models. Of these, fighter-oriented variants accounted for nearly 13,000 units. In contrast, every Republic P-47 Thunderbolt rolled off American production lines fully outfitted with 8 machine guns and a plentiful supply of ammunition. German fighter production faced increasing constraints as the war dragged on. Shortages forced many Luftwaffe aircraft to operate with lighter armament. By the final year of the conflict, some FW-190s carried only half of their intended firepower, 2 cannons instead of 4, to conserve dwindling ammunition stocks. American aircraft manufacturing benefited from expansive, well-organized facilities, with Republic Aviation alone occupying more than 1 million square feet. German fighter output, however, was fragmented across multiple sites that were repeatedly targeted by Allied bombing, a disruption that hampered production efficiency. On the ammunition side, the Lake City Army ammunition plant produced an astounding 1.6 billion rounds annually. When combined with the output of other American plants such as the Frankfurt Arsenal, the Des Moines Ordnance Plant, and the Twin Cities Ordnance Plant, total U.S. production surpassed 10 billion rounds of 50 caliber ammunition. By comparison, Germany's total aircraft ammunition output during the war, including all calibers, amounted to roughly 4 billion rounds. In practical terms, the United States manufactured more rounds for a single heavy machine gun caliber than Germany did for all aircraft weapons combined. Quality assurance practices further distinguished the two sides. American ammunition underwent rigorous multi-step inspections, with rejection rates consistently kept between 2 and 3%. German production, increasingly reliant on forced labor and substitute materials, suffered higher rates of malfunction, which directly diminished the effectiveness of their air arm. The operational impact of American air power was documented in the U.S. Strategic Bombing Survey. P-47 seconds alone were credited with destroying 3,916 enemy aircraft in aerial combat and an additional 3,200 on the ground. Beyond aircraft, they inflicted heavy damage on Axis transport infrastructure, destroying approximately 9,000 locomotives, 86,000 freight cars, 68,000 motor vehicles, and 6,000 armored fighting vehicles. These figures highlight the P-47's role not just in tactical air engagements, but in crippling the logistical backbone of the Wehrmacht. German ground forces found themselves increasingly hampered, while Luftwaffe units were unable to effectively challenge these ground attacks. American pilots were cycled back to training roles after completing 25 mission tours, later extended to 35 and then 50 missions, allowing their combat experience to directly benefit new pilots. German aviators, by contrast, often remained on the front lines until killed, captured, or rendered unfit for duty. By late 1944, the Luftwaffe's frontline personnel largely consisted of rookies facing highly experienced American veterans, widening the proficiency gap. While U.S. training programs integrated combat lessons almost immediately, German pilot training was constrained by fuel shortages and shortened schedules, producing airmen with inconsistent skill levels confronting standardized American tactics. The P-47's technological advantages amplified its combat effectiveness. Its turbocharged engine delivered full performance even at extreme altitudes, and the reliable R-2800 power plant required maintenance only every 400 flight hours. The K-14 gyro gun sight, introduced late in 1944, allowed pilots to compute target deflection automatically. Aiming was simplified to framing the enemy and firing. In contrast, German aircraft relied on reflector sights, requiring pilots to manually estimate lead angles. gun heating systems ensured the P-47's armament functioned reliably at altitudes of 40,000 feet in temperatures as low as 60 degrees F, whereas German fighters often suffered freezing of wing-mounted weapons above 25,000 feet. Maintenance infrastructure further highlighted the disparity. P-47 units maintained abundant spare parts, including complete engines, gun assemblies, and propellers, allowing ground crews to rebuild aircraft entirely overnight. Damage that would immobilize a German fighter for weeks could be repaired in a matter of days for American planes. Germany increasingly struggled to maintain operational readiness, with spare parts shortages forcing cannibalization and reducing aircraft availability. In sum, the combination of industrial scale, ammunition abundance, rigorous quality control, effective pilot training, technological innovation, and streamlined maintenance gave American air forces a decisive edge over their German counterparts. This multifaceted advantage translated not only into tactical victories but into strategic disruption of Axis logistics and mobility, shaping the outcome of the air war in Europe. By the final months of 1944, the operational readiness of German Luftwaffe aircraft had fallen dramatically, dropping below 50%. In contrast, American P-47 Thunderbolt units consistently maintained serviceability rates around 85%. This stark difference was rooted in crew training and technical expertise. U.S. ground crews were highly skilled specialists with substantial technical education, whereas German ground personnel, increasingly drawn from conscripted labor, foreign workers, and Hitler Youth, often lacked formal training and experience. Fuel considerations further amplified these disparities. P-47 seconds utilized high-grade aviation gasoline, 130 octane, permitting higher manifold pressures and enhanced engine performance. German aircraft reliant on synthetic fuels derived from coal faced fluctuating octane levels that undermined reliability and reduced engine efficiency. By late 1944, German fighters could typically carry only 30 to 50 gallons per mission when fuel was even available, while P-47 seconds routinely operated with 370 gallons internally, supplemented by external tanks. This abundance allowed American pilots to conduct multiple sorties each day, whereas fuel scarcity frequently grounded German pilots. The limited fuel also forced German aviators to conserve aggressively during maneuvers, while Americans, unburdened by such restrictions, could employ bold and sustained aerial tactics. The P-47 exemplified the American approach to wartime production, a philosophy emphasizing mass output of reliably functional aircraft. While German engineers sought technical perfection in small numbers, American designers prioritized practical performance in vast quantities. Even though the P-47 was mechanically complex, it was easier to produce than many German fighters due to standardization and mass production techniques. This approach reduced manufacturing costs, accelerated output, and extended throughout the supply chain. Ammunition standardization, such as the widespread use of 50 caliber rounds across fighters, bombers, ground vehicles, and naval units, simplified logistics and enabled economies of scale impossible for Germany's varied armament systems. German efforts to match American firepower largely failed. The Focke-Wulfs FW-190s, introduced in early 1944, could be equipped with additional cannons mounted in underwing pods, but the extra weight and drag significantly impaired its performance. The Sturmbach variant, reinforced with heavy armor and armed with 30mm cannons for bomber interception, proved vulnerable against agile escort fighters. Germany's core challenge, however, was industrial capacity. The nation could not simultaneously wage a multi-front war and match the output of the American aviation industry. Attempts to do so hastened resource depletion without producing proportional combat results. Beyond the tangible metrics of fuel, production, and firepower, the P-47 exerted a profound psychological effect. The distinctive sound of diving Thunderbolts became a source of dread among German soldiers who would seek cover at the faintest hint of aircraft. American pilots understood the morale advantage conferred by their logistical and operational superiority and approached missions with confidence. German pilots, constrained by limited resources, often engaged from a place of caution or desperation, which in turn influenced tactical decision-making and reduced opportunities for offensive action. Operational data underscores the P-47's effectiveness. Over 746,000 sorties, the aircraft achieved a kill ratio of roughly 4.6 to 6 against enemy aircraft, while losses were minimal. 3,499 aircraft lost to all causes, representing less than 0.5% per mission. By late 1944, German fighter units were experiencing monthly attrition rates of up to 50%. The 56th Fighter Group, which exclusively flew P-47 seconds throughout the war, became the highest-scoring American unit in Europe with 674 confirmed aerial victories. These achievements demonstrated that the P-47's perceived shortcomings were offset by a combination of firepower, durability, and skilled piloting. The aircraft's 850 caliber machine guns symbolized more than raw destructive capacity. They reflected America's industrial strength. Each weapon demanded precise engineering and a complex supply chain, and the ability to equip every P-47 with sufficient ammunition for sustained combat illustrated an industrial supremacy that went beyond tactical considerations. Historians widely regard P-47 firepower as pivotal in securing air dominance over Europe, with the aircraft's capacity to deliver overwhelming long-range attacks effectively neutralizing the Luftwaffe's defensive capabilities. Once the Allies established dominance in the skies, the outcome of World War II became a near certainty. The P-47 Thunderbolt played a pivotal role in shaping not only the conflict itself, but also the principles that continue to underpin contemporary air combat. Its design emphasized overwhelming firepower delivered through sheer volume, operational standardization for efficient mass production, and the strategic leverage of industrial capacity factors that remain central to military aviation today. Modern fighter jets, equipped with rotary cannons capable of firing thousands of rounds per minute, are a direct inheritor of the P-47's core philosophy. Likewise, precision-guided weapons, while technologically advanced, extend the principle of decisive firepower enabled by industrial strength rather than discarding it. When West Germany began reconstructing its air force in the 1952, it adopted American aircraft, tactics, and doctrinal concepts wholesale. German pilots trained on U.S. equipment, fired American ordnance, and absorbed the underlying strategic philosophy, an instructive example of students assimilating lessons from a proven master. While numerical data illustrate the strategic dimensions of the P-47's impact, personal accounts convey the human experience behind these machines. On June 26, 1943, Colonel Robert S. Johnson of the 56th Fighter Group survived an encounter that riddled his P-47 with over 200 bullet holes. The aircraft endured damage that would have destroyed nearly any other fighter, allowing him to return home despite severely impaired controls and a shattered canopy. Tactical innovation was equally critical. Colonel Hubert Zehner, commanding the 56th Fighter Group, developed strategies that fully leveraged the Thunderbolt's strengths. His ZMI fan formations dispersed squadrons widely, creating interlocking fields of fire that German fighters found impossible to breach. Under Zehner's leadership, the 56th achieved extraordinary success, relying solely on the P-47. From the German perspective, the P-47 was a formidable opponent. Heinz Knoke, a Luftwaffe pilot and author of I Flew for the Führer, described engagements with Thunderbolts as confronting dense streams of tracers, which effectively blocked bomber approaches and rendered escort screens nearly insurmountable. Such accounts complement statistical records, offering insight into the psychological and operational effects of superior American firepower. Behind the aircraft themselves was an immense industrial effort. At Republic Aviation's Farmingdale facility, women accounted for 40% of the workforce by 1943, producing P-47 seconds with remarkable precision under unprecedented production schedules. At the Lake City ammunition plant, workers operated in climate-controlled environments to manufacture billions of rounds, with quality control inspectors, predominantly female, rejecting any ammunition that deviated even slightly from exact specifications. This meticulous attention to detail ensured that American pilots rarely encountered the weapon failures that plagued their German counterparts, U.S. Factory workers enjoyed relatively high wages, secure living conditions, and pride in their contributions, while German production increasingly relied on forced labor under deteriorating conditions, leading to lower quality and occasional sabotage. Financially, the P-47 program represented a massive investment, costing around $1.3 billion in 1940s currency. Yet, the scale and efficiency of American industrial capacity allowed this expenditure to be absorbed alongside simultaneous production of thousands of other aircraft, armored vehicles, and naval vessels. Mass production techniques steadily lowered unit costs. Early P-47 seconds exceeded $100,000 each, but by 1945, prices had fallen to $83,000 even as performance and capabilities improved. The legacy of the P-47 extends beyond its wartime achievements. It exemplified a philosophy of combining industrial might, technological innovation, and tactical ingenuity to create decisive advantage in combat, an approach that continues to influence air power strategy to this day. During World War II, the cost of producing German fighter aircraft steadily rose, driven by dispersed production facilities and chronic shortages of critical materials, which gradually undermined efficiency. In contrast, post-war evaluations highlighted a stark contrast between German and American industrial approaches. U.S. factories relied on highly specialized machine tools, assembly line workflows, and rigorous statistical quality controls. German factories, however, clung to traditional craftsmanship methods that were ill-suited for mass production. American weapons, exemplified by the Browning M2 machine gun, were designed with mass production in mind. They consisted of simple, durable parts that semi-skilled labor could assemble using automated machinery. German weapons, in contrast, required skilled artisans and painstaking manual processes. This fundamental divergence meant that the United States could rapidly scale production, while Germany faced inherent limits. The Republic P-47 Thunderbolt, armed with 8 machine guns, symbolized the cumulative impact of these American advantages. It was not a single factor, but the interplay of industrial scale, technological innovation, logistical sophistication, and pilot training that gave the aircraft its decisive edge. Industrial capacity provided the backbone, the ability to manufacture aircraft, weapons, and ammunition in quantities Germany could not hope to match. Technological innovations, turbo-supercharged engines, precise manufacturing tolerances, and robust design ensured these resources were highly effective in combat. Logistics ensured that both materials and finished aircraft reached the front lines efficiently, and extensive training programs allowed American pilots to leverage these advantages fully. Germany, despite fielding skilled pilots, innovative aircraft, and sophisticated tactics, could not compensate for its inadequate industrial base. The Luftwaffe's initial superiority was tactical rather than material. When confronted with P-47 seconds, German pilots operating formidable planes like the Focke-Wulfs 190 discovered that traditional benchmarks of aerial combat no longer applied. The 8 Browning machine guns, supplied with seemingly limitless ammunition, represented not just firepower but a revolution in the scale and philosophy of warfare. The German experience mirrored a broader pattern of adaptation or failure to adapt in World War II. Initial confidence derived from tactical innovation and skilled aviators gradually eroded under the relentless pressure of American production capacity. Early skepticism toward the P-47's heavy design proved misplaced. Industrial might compensated for perceived tactical shortcomings. German pilots were not merely challenged by the synchronized firing of 8 guns, they confronted the reality of a nation capable of sustaining continuous output of aircraft, weapons, and ammunition. Although the 190 excelled by traditional standards of maneuverability and agility, those standards were increasingly irrelevant. The P-47, with its combination of durability, firepower, and mass production, redefined the parameters of aerial combat. This shift left a lasting imprint on military aviation. Modern fighter aircraft continue to prioritize firepower, endurance, and industrial scalability over delicate handling or individual performance. The introduction of 8 machine guns on the P-47 represented more than a technical upgrade. It was a statement of American industrial supremacy. Each burst of fire was both a literal and symbolic demonstration of resources that Nazi Germany could not replicate. The sound of these synchronized Brownings became a herald of inevitable Allied success, echoing from American factories to European skies. The P-47 did not merely outgun the 190, it outproduced, outsupplied, and ultimately outlasted German aviation philosophy through sheer material dominance, fundamentally altering the conduct of air warfare.